So, hello everybody, welcome to my talk about LibrePCB. Maybe first a quick question, who knows already LibrePCB? Okay, maybe a third. So I was here 2 years ago with my talk Introduction to LibrePCB. And now I want to give a short update what's happening with LibrePCB. So for those who don't already know, LibrePCB is a free open source EDA suite. It runs on Linux, Windows, and Mac. And yeah, the development started already in 2013, and there is slow but continuous progress. And what happened since my last talk in 2018? In November 2018, there was our first official stable release, 0.1.0. And after that, every few months, a new release was published. And I don't like to mention every feature implemented in this time, but just want to focus on some specific features. And one of these features is the library editor rule check. Probably every hardware designer knows the problem. You create a package or a symbol in your library editor. Then you add it to your design, to your PCB or whatever. And then you realize, oh no, designator label forgotten in the library editor. Or, oh no, silk screen is overlapping with the pad, or something like that. And then I ask myself, why do we have a design rule check in the board editor, but no rule check in the library editor? Because a lot of issues you can already catch in the library editor, actually. So in LibrePCB, we implemented a pretty simple, actually, check with a few rules defined. And if you violate some of these rules, you get, for example, the big scary yellow warning. There is something really wrong with your item you have created. And in the right bottom corner, you have a list of messages. What's wrong with this element. So you can already fix it in the library editor, and you're happy when you add it to your board. Another thing is the LibrePCB CLI. Actually, for most users, not that important, but I ask myself, in software development, today we use continuous integration, static code analysis, pull requests for code reviews, and so on. But for PCB tools, for libraries or projects, probably almost nobody uses such tools. For example, on GitHub, continuous integration. So, but what's needed to make this possible? We need a CLI, so you can run checks automatically on continuous integration. And for example, we have a CLI which is able to check libraries if they are valid, and yeah, more checks will be added in future. And for the base libraries of LibrePCB, those are hosted on GitHub. We use GitHub Actions to run these checks. So if a pull request adds an issue to the library, the CI will fail. The same we have for projects, so you can use the CLI or continuous integration to run the CLI to check your project if there are, for example, electrical rule check issues. And if you want, you can also automate the generation of Gerber files, BOM export, and so on. And actually, probably the most important user of this tool is Aisler, because now you can upload your LibrePCB project directly to aisler.net if you want to order your PCB. And Aisler runs our CLI to generate the Gerber files, so you don't have to generate them locally on your computer. And the best thing is, of course, for every order of a LibrePCB project, Aisler makes a donation to LibrePCB, so you can support LibrePCB by ordering your PCBs at Aisler. How to get started with LibrePCB? We have a lot of binaries or packages available. For example, for Windows, for various Linux distributions, for Arch Linux, for NixOS, even for Open Pandora, if someone knows this thing. It's an ARM processor inside, and LibrePCB runs pretty nice there. And of course, for macOS and BSD. So now I want to give a short demo to see LibrePCB in action. So let's start LibrePCB. When you start LibrePCB the very first time, you get a short wizard which just asks for a path where to store your libraries and so on. Just click through and you're ready. Then the control panel says you don't have any library installed, so it's not very useful yet, the tool. So you can just open the library manager, which fetches the library list from our API server. So this tool is also able to update your already installed library. So you can just say, oh, I want the base library. Let's install that one. It downloads the library from the internet and installs the library. You see already the warning disappeared because now you have libraries. And yeah, we can check what's inside this library. The library is scanned in the background because there are many files, so it takes a few seconds to create the index. And now we have the library elements we just downloaded. Symbols, packages, whatever. Okay, so now what's a typical use case? You also need your own local library. So let's create one, for example, because some transistor is missing in the other libraries. Then you just need a device, for example. So let's add a device, whatever. It asks for choosing a component which we want to implement. So let's say it's a MOSFET and channel, and which package you want to use, maybe TO220. These library elements, the package and the component, is contained in the base library we just downloaded. Okay, so now you have the device and you only need to create the pin map, basically. Open the datasheet, assign package pad 1 to drain, 2 to gate, and source maybe, and the pad is unconnected maybe. Okay, so now we have a warning because we didn't assign this device to a category. And the cool thing is this warning has a lot of warnings have a fix button, so you can, or even a help button, which gives some context what's wrong. And many warnings have a fix button, and in this case, it opens the category chooser. So you can assign a category. What else? Or title is not title case because the F is lowercase, so you can just fix the uppercase. Finished. No warnings. Okay, so now we have our library elements ready. So let's create a new project. Okay, and we start with the schematic, with, for example, the schematic frame. And of course, we want to add our MOSFET. I added it to the, I don't know where I added it, but we can find it. Here it is under discrete transistors. MOSFET N channel. Here it is. Okay, so let's add this one. Maybe a resistor. What else? Let's just connect them. Something very useful. That's our schematic. So let's switch to the board editor. And the board editor says we have two unplaced devices. So let's place them. And you can choose your exact device here. So maybe SMD, whatever. And our MOSFET we just created in the library. And the cool thing is we didn't create the package because someone else already created it for our MOSFET. And this package contains multiple footprint. So we can just switch to a different mounting variant, for example. Yeah, so let's create some traces, maybe. Something very simple. Okay. Now we want to create Gerber files. Yeah. Fabrication data. There you can make some settings, but defaults are fine. So let's just generate it, open the directory, and we have Gerber files here. Let's open it with the Gerber view. And here we are. So simple PCB made in a few minutes. And that's actually the main goal of LibrePCB. It should be easy to create PCBs. You don't have to spend hours and hours and hours just to know the tool. It's that easy. Yeah. What's the current status of the project? Basically, everything is working nice so far. So you can create your PCBs. There are already a lot of PCBs created with LibrePCB and order it. The main issue currently is the board editor, which needs a lot of usability improvements, and a lot of features are still missing. And so the priority for the next steps, highest priority is add the missing features like custom pad shape, blind, buried vias, slotted holes, pads, and so on, and improve the board editor to be much more powerful. Also, clipboard cut, copy, paste is not available yet in the schematic and board editors. And of course, extending the part libraries requires quite some effort. And priority 2 is adding part management for MPNs, assembly variants. 3D models is not implemented yet. MCAD, export, hierarchical sheets, and so on. You see, many things are still missing, but for at least for simpler PCBs, it's pretty usable. And yeah, if you want to contribute, I will be happy. There are several ways to contribute to LibrePCB. Just check out the website or the GitHub repository. Yeah, that's it.
So, questions, please. Why did you decide to make a new project instead of contributing to KiCad?
Very good question. I have a slide for that.
Oh, keep the question for that.
Yeah, the question was, why not contributing to KiCad and instead creating a new software? And basically, the main reasons are, I think a lot of the underlying concepts are pretty different. So I think I have different opinions how an EDA tool should work and should be designed. And usually, you, as a contributor, you can't completely change the mindset or the opinions of a different project. And the other thing is changing. If you make it happen to change fundamental things, it's very hard to keep the backwards compatibility to older KiCad or whatever projects and so on. Users wouldn't be happy if they can't migrate to the new software version. And it's much easier to create a new tool than you don't have legacy things. You don't have to provide migration paths to crappy file format or whatever. And the other thing is the target audience and the priorities is quite different, I think. KiCad is very feature rich, it's professional grade, it's very flexible. You can basically do everything with that tool. And that's not the primary goal of LibrePCB. LibrePCB focus on usability and intuitive user interface, so you can get started with LibrePCB very quickly. And also portability, stability, and the files. I would like to put files, projects, and so on under version control. And this is also a goal of LibrePCB to make it possible much better than with other tools.
So, next one.
When you're working behind a corporate firewall, applications aren't allowed to access the internet. Hence, is it possible to update your libraries through a browser?
The question is, when working behind corporate firewalls, is it possible to get the libraries through the browser?
Yes, applications are blocked.
Because applications are blocked. I mean, basically, the library manager of LibrePCB just downloads a zip file in the background and extracts it to a directory. You can get the zip file directly on GitHub. You can clone it with Git. It's no problem.
Okay, thank you.
You just can't use the library manager in that case.
So, next one.
Can you import files from KiCad?
The question was, can we import KiCad files? No, at the moment there is no KiCad import at all. There is a very simple Eagle library import, but it's a standalone application, not integrated into LibrePCB yet.
Yeah. How many active contributors on the project, or is it mainly just you?
So the question was how many active contributors we have. I think if you watch on GitHub, I think it's 20 or 30 contributors or something like that. But the main part of LibrePCB is actually implemented by myself. So the contributions are rather small usually.
Back.
Yeah, so you mentioned that you would like to put your files into Git repository or repository management. So I guess that is part I'm mostly interested in, and it's a pain in KiCad actually to not only create a board, but then to manage it, to change it, and to keep it updated. So could you give some more overview of how this could be achieved in LibrePCB? I mean, this is not part of creating PCB, but then changing something. How, for example, the libraries, if they change and I download them, won't I have any problems with that? I had some bad experiences with that on KiCad, for example, or things like that. I mean, is it all of that a focus? Changing the PCB is actually an important step, not only creating it.
So I'm not sure how to.
So let me summarize the question. How do you focus on version control?
Yeah.
Can you repeat that for the microphone?
Yeah. How we focus on version control of LibrePCB projects and libraries. So basically, the most important thing I think is that files should not contain any crap, for example, which changes everything. You open the project, close it, and files are changed. That's horrible for version control. And thus, in LibrePCB, we strictly separate information which needs to be checked in because it is important for the project or for the libraries, and information which is not that important, for example, which layer is visible or hidden or what zoom level you have and so on. that's not part of the repository in the end. That's stored only locally. So you don't have changes you don't want in the Git log. Basically.
Okay, thank you.
Thanks.